Well, good morning, Core Math 2 students. This is your Week 2 Lesson 1, and it's all about the Pythagorean Theorem and simplest radical form. So you're probably very familiar with the Pythagorean Theorem. It only works on right triangles, and the equation is a squared plus b squared equals c squared. So another way to say that is that you take the two leg lengths, square them and add them together, and that's equal to the hypotenuse length squared. So it's important that our C value is always the hypotenuse, or the longest leg in the triangle. It's always across from that right angle. That's where we can find it. So one of the questions that you might run into on Delta Math is, what does it mean by writing down an exact answer? Well, it could be a couple of things. It could be that your answer is a whole number, so that's exact. But what if your answer ends up being a crazy, irrational decimal? What do we do with that? How do we make sure that we write that as an exact answer? Well, that's where simplest radical form comes in. So let's take a look at a couple of examples here. Example 1, we have a right triangle with a leg of 12, and then the hypotenuse is 20. So when we go to set up this equation to find the exact length of the third side, we want to make sure we take our leg, and we can call that 12 length either A or B, doesn't matter, and the other leg is missing. So give that the other variable. So we've got 12 squared plus the unknown b squared, and that's equal to the hypotenuse length 20 squared. So we'll have to do some evaluating. 12 squared is 144. 20 squared is 400. And then we need to do some solving. We need to move things across the equal sign. So subtract 144 off of both sides. That leaves us with b squared equals 400 minus 144, that's 256. Use the Delta Math calculator or the calculator on your phone to get that. And then the last step is to finish finding b by applying a square root. So let's first check to see if this happens to be a whole number. If it is, we're done. The square root of 256 is 16. This is a whole number. That is an exact answer. So that's what we would write down for our leg length, the leg length. And just double check, make sure that leg length is smaller than the hypotenuse value, because the hypotenuse has to be the longest. All right, so what about other problems? So here in example 2, make sure that's a right triangle. Pythagorean theorem only works on rights. So we have a leg of 4, a missing leg, and then the hypotenuse is 8. So again, you can call this 4 length B or A. It does not matter. So when we go to set up our equation, a squared plus 4 squared equals the hypotenuse length 8 squared. So we do a little evaluating. 4 squared is 16, 8 squared is 64. And just like before, since we're finding the leg length, we do need to start subtracting across the equal sign. So here's what we know. A squared equals 64 minus 16. So that is 48. And then our final step would be to apply that square root. Let's see if that's a whole number. It's not. It's an irrational decimal. So we can't write that as an answer because that's not going to be exact. No matter what we do, there will be some rounding there and it's no longer exact. So instead, we need to take the square root of 48 and break this down into simplest radical form. We've done this before this year, but it's been a little while. So we might need to remember some things like, what are perfect squares? 1 squared is 1. That means 1 is a perfect square. 2 squared is 4. That means 4 is a perfect square. 3 squared is 9. So 9 is a perfect square. 4 squared is 16. That's a perfect square. So you can create these lists of perfect squares by just going through and squaring every whole number 1 through 10 or beyond. 7 squared is 49. 8 squared is 64. And you can keep going. And all of those numbers I've circled, those are perfect square numbers. And let's just finish off the list through 10. Here we go. And 100. Okay. So how we go about finding the simplest radical form is we're looking at this number 48, and we're trying to break it up into a product of two numbers. And we want one of the two numbers to be the biggest perfect square possible. So 48, we're not going to worry about anything that's bigger than 48, but is 48 evenly divisible by 36? would that be a perfect square factor of 48? Well, the answer to that is no. Is 48 divisible by 25? No, not evenly divisible. Is 48 divisible by 16? Ooh, yes, it is. So that's a whole number pairing, 16 and 3. So the square root of 48 is the same thing as the square root of 16 times 3. It's all equivalent. And the special part is 16 is a perfect square. So we keep going. We keep breaking this down into the square root of 16 times the square root of 3. So we can split those up into two separate square roots. And then we can actually say, hey, we know the square root of 16 is 4. And so our final answer is 4 times the square root of 3. Because that part, we can't take the square root of 3. It's not a perfect square. So our final answer is 4 times the square root of 3. Head on over to Delta Math, work on those practice problems. Good luck out there.